In the prior video, I went ahead and solved only this problem here because it was that difficult. And we're just going to keep going through the problem set here to see what we get. So just as a quick reminder, we are trying out some of these new rules where the derivative of sine is cosine and the derivative of cosine is negative sine. That's all that's new. We have the power rule, we have the exponential rule, we have the product and quotient rule. Those are the only derivative rules we know. So that means that that's all that should be necessary, right, for us to solve the remaining problems. I'm going to start with the first one because he's the easiest. Oh, we don't want a thin pen like that. Come on now. Let's go with about 8 pixels. 3x squared minus 2 cosine x. Now these are separated by simple addition, which means we can use rules separately to solve them. This one's a power rule, straight up. You've done this a number of times now. And minus 2 is not part of the x function, it's just a multiple, so that will stay the same. And the derivative of cosine, well, we have it, mark it in white, we have it right here, don't we? It's negative sine. If I can get it to work. Negative sine. There it is. It's working. Doesn't that help? So we end up with 6x plus 2 sine of x as our derivative. I should have written that part out just to make sure it was clear, but I'm sure you're following. So that one wasn't so hard. The next one, I don't know about that. Now we got some trig functions, so they're asking us to understand some things here that we might not be ready to understand. F of x equals sine of x plus 1/2. I'm going to write it like this. And cotangent is cosine of x over sine of x, isn't it? And I always write, what's happening? There it goes. I always write in terms of sine and cosine, because I can't remember otherwise. So let's find the derivatives here. Well, the f prime of x, that's going to be easy at first. That's a cosine over there. We just learned that. But over here, we have more of a quotient rule, right? And the quotient rule says u prime v minus v prime u, and all of that is over v squared. So what's our u? That's cosine x. What's our u prime? That's negative sine of x. What's our denominator? Sine of x. What's our v prime? Cosine of x. This should be all we need to work this out. So u prime v would be negative sine of x times sine of x minus cosine of x times u is cosine of x again. That's interesting. And this whole thing will be divided by sine of x squared. You notice I like to put the squared outside the function because that's where exponents should go, outside of the function. People who write sine squared x this way, they'll never be able to explain to you why that's better, my opinion. So don't ask me to write it that way, I'll just say it now. Okay, so condensing these, kind of coming down to the left is a little strange, I know. Let's make it a minus, since there's a couple of minuses. Sine of x squared plus cosine of x squared over sine of x squared. Well, this is equal to 1, so this is 1 over sine of x squared. And for our f prime, that would give us cosine of x plus 1 over 2 sine of x squared. And if you really, really wanted to, instead of writing it this way, you can write it as 1 over 2 cosecant of x squared. I don't know why people do this. I really don't know. It's only more confusing to a newer student. I prefer to keep things in terms of sine and cosine because when you're doing derivatives, you're going to want to use sine and cosine. So this is the answer here. This is the answer for that one here. What about the remainder there? I want to cross that right off. So let's erase all of these. Thank you for your help, cheat sheet work. But it's time for you to go away in lieu of more help. Okay, next. F of t. See why it's t? These are functions of t, which means this t squared isn't a number like 5. It's a derivable, differentiable. It's a differentiable functional value thing. So we have an f of t. We have a function of t. C cosine of t. Couldn't have picked a worse variable to put in front of the cosine than another c, plus t squared sine of t. Okay, so c is just a number like 5, and maybe it comes from a different function, but we are taking f prime of t. So we don't care about c, and that's not going to change anything. So that'll be negative c sine t plus, we have a problem here because these are two different t functions that are multiplied, and our product rule up here says two functions of the same dx here, right? U prime v plus v prime u. Are you getting tired of it yet? I hope not. I hope not. What's our u value? We'll put just a barrier over here. Our u value is t squared. So our u prime is going to be 2t. What's our v? Sine of t. What's our v prime? Cosine of t. Right? So we're going to get u prime v plus v prime times u. So our final answer, can that be simplified at all? We can take a t out of it. I'll see what we can do here. And there's signs over here. Maybe we'll play with it a little more. Let's see what happens here. F prime of t is equal to negative c plus 2t sine of t plus t squared cosine of t. That might be where I leave it. I prefer to have it totally worked out. Maybe a different way to write it, and the easiest way to write it would leave it be somewhat like before, where it'd be negative c sine of t plus 2t sine of t plus t squared cosine of t. All of those will work. All of those will work. So in the next video, we'll conquer this one because I think we're going to get another difficult differentiable. I'll see you over there.